Welcome back, PlayBASIC coders. This is a quick update. Our ideas on returning values from functions without doing it explicitly. So we had like a little return structure. These functions here are called dynamically, by the way. And to get data out of them, we're pushing it onto a type structure and then reading that type structure off at the end, which is kind of demonstrating up here in this example. This example's got bigger, but the prints, that hasn't changed. The other one is obviously, what if you were wanting to call a variable number of parameters on a function? Now here I'm calling the function by its actual text name in the source code and not passing it any functions here, but maybe I want this a variable amount of this stuff here and not have to have a table of all of the different patterns to call, So what you could do is have something like here, which is a little stack of these parameters. The function just clears the parameters out so it's empty before we start pushing onto it. We push on an integer value of name X, an int value of name Y, a string called title, and a thing called junk. Now, if we skip down to this working function here, there's a little decoder loop inside the function. So we haven't really got associative arrays, so we've got to sort of conceptualize a way around that. Now you could have a push and a pop mechanism. You could have like up here, you could have like pop, whatever the things were, pop string, and this could be title. That has issues about when you call the work function, about knowing what kind of pattern you're pushing to it, and then ultimately popping from it. So what I thought is, if we just use a name concept where we associate a name with each bit of data, we can then use a simple loop to decode these parameters up front and then do our function here. Our function is just drawing a circle and with a text on it. I mean, it's so trivial. Let's run it. So calling this function number one has given us the appropriate location and our message as well. The other functions don't have anything, so they don't even respond to that. Like when this function here is being called, I'll draw a box or something like that. 700, 100, 750, 800, true, and we'll make it red. I want a colored box. So when function 2 is called, it should draw us a box off to the side there. So we know that's being called. Normally you wouldn't be able to do that. You can't call a function and have this thing pushing these parameters up here. It works because we're just ignoring those things completely. We don't need them in this case here. Same goes to the other one. Yeah. So you would need some variables, parameters that made sense, but it's one way you could tackle it. It's not pretty, but you could tackle it that way. And internally, the way this works is that if we have a look at this little variance thing over here, so it's just calling each one a variant, and internally it has the name of the variant, our data type, and then our three simplistic forms of data. We've got our integer value, a floating point value, and a string. You could have more, but that's all I've just bothered to add to this thing here. We've got a couple of just arrays up here, typed arrays, that hold the current parameters and the input count of parameters. So the little functions we were using before, the flush just resets the counter. So we're just adding things onto this array here as we push. And then as we iterate through them, we just call param name and as long as we skip unknown parameters, so if we have a little loop here, we call give you the name of the next parameter, and then we're determining what to do with that parameter in this particular function. So we're finding it by name, but if the name isn't unknown, it's something that this function doesn't need, then we need to skip over it by default, and that's what the skip parameter is doing here. If we query parameter, it happens to be the X thing, we can then call get param int. So the functions are all basically the same. We're just popping this value off the parameters count, checking to see what data type of this thing is, and then returning whatever data is in this thing currently as an integer back to the caller. So if this thing was an integer, which I've just tagged here as being type 1, we really should have a descriptive value there to tell us what that actually is, but I haven't bothered. If it's type 2, it's a float, so we read the float field. And we're pulling the float and returning it as an integer. If it's case 3, it's a string. So if it's this, we do a val of that string. In other words, we convert that string into an integer and return that. So it won't error if the wrong thing is being stored there. Same goes for returning a float, except we're just focusing on returning floats. If we query something and it happens to be an integer, then we grab the int and return it back as a float. If it's the float, we just return it back as is. If it's a string, we get the val of the string and return that back as a float. If it's a string and the thing we're looking at is an integer, we just do the same thing. We just get a string of that number, put it in here, our exported result. So it's not pretty, but it's fairly fault tolerant, I guess, to a point, because we are worried about wanting certain things and not wanting other things. I guess what you could do to make it more project specific is that here we're using very generalized terms. We're saying we just want to deal with integers, floats and strings, but maybe a better way of laying it out in your case would be that, hey, if you had like a push vector here or something like that, and you could go, push the position of something and then give it like a 2D vector, give it the x and y components of the vector. And then on the other end, it's just grabbing, hey, give me the position, and then it's getting the x and y out of that thing. A little less decoding, and it would customize the approach to your problem, if that makes any sense. But anyway, the very straightforward idea. Another way of doing the same thing really would be have a structure that has all of the possible input data that all of the functions you're calling could have. So it could be like up here. So it could be like type t input params, whatever. If I can spell it, that'd be good. Since we've used, what variables we use? We've used x, y, and title. We can have an x variable and we have a title. And, I don't know, something else. What about color or something like that? I mean, who knows? Whatever. Have all those things there. Have a structure that we fill in each time we call a function, and then inside each function it just grabs the fields that it needs. So it's called inputs. A pointer to that, and let's allocate. Inputs equals new. Yep. So rather than this push mechanism here before the call, you'd have like inputs x equals 600. What have we got? What else have we got there? Y equals 200. Inputs dot title. Dude, where's my car? Classic movie, people. Classic. I mean, how can you not love that movie? Pretty easily, I guess, but anyway. Then up in here, I think you'd have to pass this. You have to pass you might need to pass it as an integer, actually. You might have to force that to be an integer. So on this calling side here, if we just kind of delete that for a second, just call it something else. And our other functions won't like this if we try and run this, so that's not going to be good. Yeah, we won't modify the other code. We'll leave that the way it was. We'll make a second one here. Work function, we'll just call it test. And we'll have params as t input params pointer. Thanks. So up here we would have this thing. So you'd go x equals, params x, whatever. That's definitely a faster way of doing it, and if the pattern of your functions, if the variance in the inputs of your functions is small enough, if there's let's say you've got 10 parameters that may or may not need to be passed to all of the functions in the group that you're calling from, then yeah, why not? Title. Space out a bit so you can see what the hell's going on. This is fetching our. We could just use those things in here directly, but I tend to like having local variables do that. We'll just try a test in the bottom. Let's put it below this actually. That's our inputs. And we're passing into this guy. Inputs, yeah. That'll draw the circle over the same place, but we might change the color this time. Let's change it to a green circle, and we'll displace it by 200 pixels. So we'll just go x plus equals 200. Simplest way to do that. Oh, I've got green text. It's alright. We want a green circle, and we just tell it that actually. The graphics commands sort of have two behaviors. They either grab from the current ink color, or you can tell it you want to use a specific ink, and that's what the C version of those commands is, just in case you're wondering. Now, the other function is not being called. We've changed the name of it. It's just, if it can't find that, it just doesn't do it. If I come back here, work function, I think it was what have we done there? Oh, sorry, we're passing inputs to that. That won't match. Should have two of them, yep. So our green one is the one we passed our input structure across into, and the white one is the one we're fooling around with the idea of pushing pushing a bunch of parameters to our little makeshift stack and then retrieving them. I think in most situations, something like this is probably the more appropriate method. In others, maybe not. I'll just put that params. Let's add him up to here. So if we draw a line this time, params x y, I don't know, some random value. In other words, we could do both. We could actually have our stack stuff, and we could have our inputs. Sorry, if we do this. Now, I realise that's hard to follow what's going on, but in other words, we could use our structure. I'll copy this up here actually. Or we could fill out a structure here, and this is being passed to every one of those functions that meets this name, where it's been called by call function. The ones down here, work function. So we have this input parameter here of this input structure, or we could push on our extra data if we wanted to. So I guess that's probably an easier way of doing something, really. If you have very specific and if your functions are very different in behavior, then you might need to have a pattern that works more like that. Yeah, I'm sure it's hard to wrap your heads around, but there's a couple of different ways there of tackling the same basic problem. They're not pretty, granted, they're not pretty, but it can be done, and for all intents and purposes, it's not that hard to do. Anyway, dudes, see you next time. Bye.